1,000 years ago, a farmer in medieval England looked up at the night sky and saw something you will never see. Not a different sky, the same stars, the same constellations that hang above you tonight. And yet, everything was different. That farmer saw a river of light so bright, it cast shadows on the ground. He saw 9,000 stars scattered across the darkness, while you, standing in your backyard tonight, might see a few dozen. He watched the heavens turn around a different point than you do. And if he was alive on May 1st in the year 1006, he witnessed something no human alive today has ever seen. A star so brilliant it outshone the moon, visible even at noon, bright enough to read by at midnight. The night sky has not changed, but our ability to see it has been transformed beyond recognition. This is the story of what we lost and what our ancestors saw that we can barely imagine. Before we understand what changed, we need to understand what our ancestors actually saw. Under truly dark skies, the kind that existed everywhere on Earth before the 19th century, the human eye can perceive approximately 4,500 stars at any given moment, and over 9,000 total across both hemispheres. These aren't abstract points of light. Many of them have color. Blue giants, orange supergiants, red dwarfs painting the darkness with subtle hues that modern eyes, blinded by ambient light, simply cannot detect. But the real revelation was the Milky Way. Today, nearly 3 billion people on Earth have never seen it. Not because clouds blocked their view, not because they weren't looking, but because it has been erased from their sky by the glow of human civilization. In a truly dark location, the Milky Way isn't a faint smudge. It's a vast, luminous river, a band of light so dense with stars that ancient observers could see dark patches where cosmic dust blocks the light behind it. Some cultures believed it was the backbone of the night, a celestial road, or the path that souls traveled to the afterlife. The ancient Greeks named our galaxy from the word galaxias, meaning milky. They could see it so clearly, they named an entire class of cosmic structures after that white glow. As recently as 1917, astronomer Guillaume Bigourdon could observe the Milky Way from the Paris Observatory during summer nights. 100 years ago, you could see our galaxy from the center of the City of Light itself. Today, most Parisians have never seen it. In 1994, a 6.7 magnitude earthquake struck Los Angeles. Power lines fell, transformers exploded, the city went dark. And then something unexpected happened. Emergency centers and the Griffith Observatory were flooded with calls from concerned residents reporting a strange phenomenon in the sky, a giant silvery cloud stretching from horizon to horizon. Some wondered if it was smoke from fires. Others thought it might be some kind of atmospheric phenomenon caused by the earthquake. It was the Milky Way. Millions of people were seeing their own galaxy for the first time in their lives, and they didn't even recognize it. This is what light pollution has done to us. It hasn't just dimmed the stars, it has severed our connection to the cosmos itself. We have become the first generation in human history to grow up unable to see our place in the universe. The problem began innocently enough. The first streetlights appeared around 1000 AD using simple oil lamps. They were weak, flickering, barely visible beyond a few feet. Gas lamps followed in the early 1800s. Then came the electric bulb, and everything changed. By 1902, the Melbourne Observatory, established in 1863, had to abandon astronomical observations because the light pollution from the growing city made precision work impossible. Paris followed. Observatory after observatory retreated from the advancing glow of civilization. Today, light pollution increases globally by nearly 10% every year. Over 80% of the world's population lives under light-polluted skies. In places like Singapore, the sky never gets darker than perpetual twilight. The human eye cannot fully adapt to true night vision, a process that takes 30 minutes in complete darkness. Because complete darkness no longer exists for most people. Under pristine conditions, a person with good eyesight can see stars as faint as magnitude 6.5, dim ancient suns barely visible, requiring perfect darkness and patience. In a typical city center, you might see magnitude 3.0 at best. That's the difference between 9,000 stars and maybe 200. The medieval farmer saw 90 times more stars than you do. But light pollution isn't the only thing that's changed. The night sky itself has shifted, and in a very real sense, we are looking at a different sky than our ancestors. Consider Polaris, the North Star, the steady point around which all the heavens seem to turn, the guiding light that has helped navigators find their way for centuries. Except, it wasn't always there. In Shakespeare's Julius Caesar, the Roman dictator declares himself constant as the Northern Star. It's a beautiful line, and it's astronomically wrong. In Caesar's time, there was no constant Northern Star. When the real Julius Caesar looked up at the sky around 44 BC, Polaris was more than 10 degrees away from the celestial pole, about 20 times the width of the full moon. It wandered across the sky like any other star. The Greek navigator Pytheas, sailing around 320 BC, specifically noted that the celestial pole was devoid of stars. There was no North Star because no bright star happened to be near the pole. This happens because of precession, a slow wobble in Earth's rotation, like a spinning top beginning to slow down. Our planet's axis traces a great circle across the sky, taking approximately 26,000 years to complete one full cycle. As it wobbles, the point around which the stars appear to turn shifts gradually from one star to another. Polaris only became our North Star relatively recently in human history, within the past 1,500 years or so. Before that, the nearest bright star to the pole was Kochab, which served roughly from 1500 BC to 500 AD. Go back further to 2750 BC, and the Egyptians used Thuban, a dim star in the constellation Draco that aligned with the pole so precisely that some believe the Great Pyramid's descending passage was built to point directly at it, and Polaris won't last forever. It will reach its closest approach to true north, just 27 arc minutes away, around the year 2100. Then it will begin drifting away, and by the year 14,000, a different star will reign. Vega, one of the brightest stars in our sky. If your great-great-great-grandchildren look up in 14,000 years, they will navigate by a completely different star than you. For thousands of years, humans called them the fixed stars. Eternal, unchanging points of light, permanent fixtures in the cosmic order. The planets wandered, hence their name from the Greek word for wanderer. But the stars stayed put, until 1718, when Edmund Halley, yes, the comet guy, made a startling discovery. Halley had access to ancient star catalogues compiled by Hipparchus around 128 BC and later refined by Ptolemy. Comparing these 1800-year-old positions to his own precise measurements, he found something impossible. The stars Sirius, Arcturus, and Aldebaran had moved, not by much, about half a degree, roughly the diameter of the full moon. But they had definitely moved. The fixed stars were not fixed at all. They were all in motion, drifting through the galaxy at tremendous speeds. We simply couldn't perceive it because the distances involved were so vast and the motions so slow. Arcturus, the fourth brightest star in our sky, moves at about 2.228 arcseconds per year, fast enough that over 2,000 years, it has noticeably shifted position relative to its neighboring stars. Today it sits at the base of the kite-shaped constellation Betelgeuse, but 3,000 years from now, Arcturus will have drifted between two nearby stars, as if the herdsman is doing the splits. Altair, in the constellation Aquila the Eagle, flanked by two dimmer stars that form the eagle's ears. In Babylonian times 3,000 years ago, those three stars formed a different pattern entirely. Altair sat below them, not between them. Even the Big Dipper, perhaps the most recognized pattern in the northern sky, is slowly changing shape. 5 of its 7 stars belong to a group that form together and travel through space in the same direction. But the other 2, Alkaid and Dubhe, are moving differently. Over tens of thousands of years, the Dipper will stretch and distort, its familiar ladle shape warping into something unrecognizable. The constellations our grandchildren's grandchildren see will not look like ours. The patterns are temporary, frozen snapshots in the slow motion of cosmic time. The medieval farmer who looked up at the sky 1,000 years ago may have witnessed something else that you never will, a star being born, or rather, dying. Chinese astronomers called them guest stars, sudden visitors that appeared without warning, blazed brilliantly for weeks or months, and then faded into oblivion. Today we know them as supernovae, the cataclysmic explosions of dying stars. If you could travel back to May 1st, 1006 AD, you would witness the most spectacular stellar event in recorded history. That night, in the constellation Lupus, a star exploded 7,200 light-years away. The light from that explosion reached Earth and created a guest star so bright that Egyptian astronomer Ali ibn Ridwan compared it to 1/4 the brightness of the moon. It was 16 times brighter than Venus, the brightest object in our sky after the sun and moon. It cast shadows on the ground. It was visible in broad daylight. For weeks, you could have used its light to read at midnight. Records of SN 1006 survive from China, Japan, Iraq, Egypt, Europe, and possibly even North American petroglyphs. The entire world noticed when a new star appeared that outshone everything else in the heavens. Less than 50 years later, on July 4th, 1054 AD, another guest star appeared, this time in the constellation Taurus. It wasn't quite as bright as SN 1006, but it was spectacular nonetheless, visible in daylight for 23 consecutive days, and remaining visible to the naked eye for 653 days, almost 2 years. The remains of that explosion are still visible today. We call it the Crab Nebula, a twisted cloud of gas and radiation. At its center, a pulsar spinning 30 times per second, a cosmic lighthouse beaming across the universe. Ancestral Pueblo peoples in what is now New Mexico may have recorded this event in rock art. A famous petroglyph in Chaco Canyon shows a crescent moon near a star-like symbol, and on the morning of July 5th, 1054, the crescent moon came remarkably close to the supernova, visible only from Western North America. The last supernova, visible to the naked eye in our galaxy, was Kepler's star in 1604. That means no human alive today has ever witnessed a naked eye supernova in the Milky Way. We've gone over 4 centuries without seeing what our medieval ancestors witnessed twice in the span of a single lifetime. But the universe keeps trying to show us things. In the winter of 2019, something strange happened to one of the most recognizable stars in the sky. Betelgeuse, the red supergiant marking Orion's shoulder, began to fade, and fade, and fade. By mid-February 2020, it had dimmed to less than 40% of its normal brightness. Normally one of the 10 brightest stars in the night sky, it had dropped to a mere shadow of itself. Amateur astronomers around the world could see the change with their naked eyes. Orion looked noticeably unbalanced, his shoulder visibly dimmer than his foot. The astronomical community went into overdrive. Betelgeuse is a dying star, a bloated red supergiant that has swelled to 700 times the size of our Sun. If it replaced our Sun, its surface would extend past the orbit of Jupiter. Astronomers know it will explode as a supernova someday. Predictions range from tomorrow to 100,000 years from now. Nobody knows exactly when. Was this the beginning of the end? Was humanity about to witness the first naked-eye supernova in over 4 centuries? It wasn't. But what actually happened was almost as remarkable. Using the Hubble Space Telescope, astronomers determined that Betelgeuse had blown its top. A massive surface eruption had ejected a chunk of the star's atmosphere into space, 400 billion times more material than a typical solar coronal mass ejection. This superhot plasma cooled as it traveled outward, forming a dust cloud that partially blocked the star's light from our view. The Great Dimming, as it came to be called, wasn't a sign of imminent explosion. It was a violent sneeze from an old, unstable star, a reminder that even the familiar points of light in our sky are not static objects, but dynamic, churning nuclear furnaces subject to their own chaotic processes. By April 2020, Betelgeuse had returned to normal brightness, but scientists now believe the eruption disrupted the star's internal pulsation cycles. It's still recovering, still bouncing back from the trauma of ejecting a piece of itself into space. And here's something to consider. Betelgeuse is about 725 light-years away. The light we see left the star around the year 1300. The Great Dimming we witnessed in 2019 to 2020 actually happened during the reign of Edward II of England, while Dante was writing the Divine Comedy. We are always looking into the past, so why does the night sky look different than it did 1,000 years ago? Not for any single reason, but for all of them at once. The sky has been stolen from us by our own light. Nearly 3 billion people have never seen the galaxy they live in. We've traded our connection to the cosmos for the convenience of illumination, often without even realizing what we've lost. The dark sky that our ancestors took for granted, that brilliant river of stars that inspired myths and religions and the earliest science, has become invisible to most of humanity. The sky has shifted beneath our feet. Earth's slow wobble has changed our pole star, moving the center of rotation from emptiness to Thuban, to Kochab, to Polaris, with Vega waiting patiently 12,000 years in the future. The entire coordinate system of the heavens has rotated by about 14 degrees since the year 1000 AD. The stars themselves have walked across the sky. Arcturus and Sirius have shifted by roughly the width of the moon since ancient times. The constellations are not eternal patterns, but temporary arrangements, snapshots in the grand motion of the galaxy. And our ancestors witnessed cosmic events that we can only study through telescopes and ancient records. They saw stars explode and appear from nothing. They watched the heavens transform before their eyes in ways that modern humans, even with all our technology, have not experienced firsthand. The medieval farmer's sky was darker, richer, more alive with light and drama than ours could ever be. And yet, in some ways, we see further than he ever could. Our telescopes pierce depths he couldn't imagine. Our satellites map light invisible to human eyes. We understand the physics of what makes the stars shine, what makes them move, what makes them die. Here is what you can do tonight. If you live near a city, drive an hour away from the lights. Find a hilltop or an open field. Give your eyes 30 minutes to adapt to the darkness. Truly adapt, without checking your phone, without any stray light at all. And then look up. What you see will not be what the medieval farmer saw. The stars will be in slightly different positions. The pole will be closer to Polaris than it was in his time. Some of the guest stars he saw are now fading nebulae, visible only through telescopes. But the river of light will be there. The Milky Way will arch across your sky like it arched across his. The depth of the darkness, punctuated by thousands upon thousands of ancient nuclear fires, will take your breath away. This is the view that shaped human consciousness. Every culture, every mythology, every early attempt to understand the universe began with people staring up at exactly what you're seeing. The patterns they traced, the stories they told, the questions they asked, all of it started here, under this canopy of light. The sky is still there, behind the light pollution and the city glow. The Milky Way hasn't gone anywhere. The stars continue their ancient journeys. The galaxy turns, imperceptibly slow, carrying our sun and our planet and all of us along with it. The view has changed, but the wonder remains. You just have to know where to look.